And I'm not going to write the definition of a function now because you already memorized it, right? What is the definition of a function?
When a relationship in which one aspect of the domain correlates to exactly one aspect of the range.
Close. A relation in which every element of the domain corresponds to exactly one element of the range. Turn and share with the person next to you the definition of a function. Go. See if you ever said it. Go.
What's this the relation in
a relation in which every element of the domain corresponds to one element of the range.
Everybody together, ready? A relation in which every element of the domain corresponds to exactly one element of the range. You can do it? I know you can. The domain is the inputs. It's the x values. The range is the outputs. It's the y values. Simple as that. Today we want to graphically be able to look and be able to identify domain and range. Now, on the test, you guys are excellent at finding the domain and range when you look at the graph. I take the graph away, and it's not so good. I'm going to do my best to teach you all today, but I would say about a fourth of students walk onto the test, and they don't know how to do the second thing I'm going to teach you today. I'll try my best. I will do my very best. I've adjusted over the years, and I'll continue to try, but it is what it is. So make sure you're focusing at that time. I have these graphs. You're going to try to, I don't have them on your paper, so I'm going to give you a little bit of time to draw these shapes. Whoop, don't do that. And all you need to do is kind of get the dots in the right spot and just draw the shape from there. So I have -3, 0. I have -3, 1. I have 0, 3. I have no glasses today, huh?
I have not today.
Do you wear contacts?
No.
So you need the glasses? Or are they just for style?
I need them.
Okay.
I just don't like wearing them.
You were wearing them the other night at the football game.
Yeah. Because I can see the scoreboard.
So you can see the scoreboard. I got it. Adrian, I did not see you at the football game.
When?
Friday night.
I was working.
It was the place to be. Where do you work?
Qdoba.
Qdoba.
Yeah.
What's the best thing to purchase at Qdoba? What's your favorite order?
It just depends, I guess.
Ooh, depends on the day.
Yeah.
Okay.
Yeah.
Mr. Ruth and I tend to go there about once a year together. I buy his lunch for him. It's because I got lots of money. Okay. Oh, you're trying to draw the bottom ones too. Sorry. Yep. So we're going to practice this. I'm going to give you about 5 minutes in class to start working on those examples. And then after that, we're going to move on to the second piece. Everybody good? Okay. I would like to identify the domain and the range of this graph right here. And as I identify the domain, I like to imagine taking a vertical line and dragging it across. So as I am sitting right now at an x value of -5, does the graph have an output at -5? Yeah, it has a height of about 1.5. So I know that -5 is part of the domain. So I drag it over here. Does the graph have an output at 0? Yeah, it looks like it has a height of about 1, 2, 3, 4, somewhere about that. So 0 is part of the domain. And you see these arrows go on in those directions. The question is, suppose I had the vertical line sitting over here at -9. Would the graph sometime go over there as well? So you can see that this domain is all real numbers or from negative infinity to positive infinity. If you wrote that or all real numbers on the test, I would give you credit. Now the range is slightly different. Instead of doing a vertical line, I actually grab a horizontal line, okay? So I'm gonna grab this horizontal line and I start at a height of, well, down here, come on, there we go. All right, so I'm down here at -7. Does the graph ever come down here? -1? No, it doesn't start until I get to 0 and it goes up to infinity. So therefore my range is from 0 to infinity. That is your range. Okay. Next one, I do the domain and I start the domain at, where do I start to pick up x values? Come on, there we go. Where do I start to pick up x values? -3, and it carries on to infinity. And the range, you can see that I don't start to pick up values until I get to 1, all the way up to infinity. Do number 3 on your own. Glance up when you're done, see if you got it right.
Oh, it's due.
Everybody good? Okay, let's move to these next 3, and then you can work on your assignment a little bit. This is different because our graph has some broken parts to it. So the domain starts by picking up a value of -4, and notice how it goes over to -3, -2, but at at 0, you have an open circle. But then it picks up with a closed circle down at -2, doesn't it? And then it continues on until 3. So therefore, even though it's broken, the domain is all the way from -4 to 3, because I have outputs for all those x values between -4 and 3. If you look at the next one, the range is dramatically different because I only have 2 values in my range. What are the 2 values I can get?
-2 and 5.
Yeah, -2 and 5 are the only ones, and I can't get anything in between there. So therefore, when I list the range to show I only have the values of -2 and 5, I use what we call roster notation. Kind of like you were to list the numbers on a team, for example. So only -2 and 5 are elements of that range. Only -2 and 5. Question?
Would it work if we just went 5 to -2?
No.
Why?
Got to have the roster notation. So, and we could push further and say, do I understand what Grant is saying? Possibly, but you will never see that expressed on the ACT or in any math class after this. This is the notation that you will see, and that's why we practice it. So you're right in saying that, but that's how it's got to be expressed. Okay, the next one, domain. Where do you start? Yeah, you start -5, and it's only the value -5, isn't it? And then it takes a break. It doesn't pick up values again until what? -3 to infinity. And then the range starts where? -6, and it goes up until -2. And it takes a break at -2. It does not include -2. Union, and I pick up with 1, and I go all the way up to 4. Talk with the person next to you. What do you think about the domain for the next one? Just talk about the domain for the next one. What do you think about that last one? Think about it.
But it would, no, it wouldn't. It would never hit. Super close.
You think?
I think that'll be it would.
Yeah,
Think?
Alex is he's bringing up a really good point here, and you don't know this unless a teacher really explains it and says it. But the nature of this graph is intended to show a graph that gets really close to zero, infinitely close to zero, the x-axis or the y-axis, but never actually crosses it or touches it. That's what it's trying to show there. So as you look at your domain, you should pick up from negative infinity, but then when do you run out?
0.
At 0, and you do not include that 0. But then you pick up just on the other side of 0 and go all the way to infinity. So what's the only value that is not included in your domain?
0.
So therefore you could just write x cannot equal 0, and that would be another exception or acceptable result for your domain. Similarly, in the range, y cannot be 0 either. So it's exactly the same. We just say that y cannot be 0. That's a graph of what we call a hyperbola. We end up seeing a lot of those as class moves forward, and so this is going to help you as you see some other pieces. What I'd like to do is I'd like to pause in class right now. I'd like to give you 8 minutes to be able to work on your next assignment. Your next assignment appears to be out of order. I apologize for that. I am a horrible teacher. But I ask for your forgiveness. You want to turn to this one right here that has the bold graphs on it, okay? You have the front and back that has those shapes. Go ahead and start finding the domain and the range for those. When we get to about 241, okay, give you about 8 minutes, about 241, we're going to continue on with this section right here, okay, that section right there. I need to run a quick errand. We are going to leave. Who should we leave in charge? We're going to leave Tyler in charge. Tyler, can you handle this group? Okay, who would be your first line of defense? If you were to call on somebody for assistance in this room, who would be your first go-to?
Me. Okay, Ben.
Ben, wow. Bracken, you were not even considered. Not even considered. Okay? And Adrian, nor were you, even after he found out that you worked at Qdoba. I would say that would be very qualifying. But, oh well, teach your own, Tyler. Good luck. Survival of the fittest.
He just respects my guy.
Just kidding.
I got you.
What does that mean?
What?
Whatever you just said.
Yeah.
You don't know, then you don't know.
He was gonna go yell at the jump to us. And the squinkless. What's better, Mexiban or Bandero?
I like Coach K can say today.
Well, he said we had a.
That we're not trying hard enough.
Yeah, for tomorrow with him. Say,
You ain't gonna put 200%, don't you?
he's gonna say,
Hey, Ben.
Yeah, what do you want?
What else?
he's gonna say.
Let's kick my ass
For
tomorrow.
ours?
-5, comma,
What's he gonna say?
-2,
It'd be like,
brackets, union, 0,4 with brackets.
if y'all want to come play 100% tomorrow,
Domain.
then don't show up.
-4, -3, and this is gonna be -5.
Or like
To
Lucas said,
this,
that we're gonna have to defend a lot in this game.
0, 4. Type beat.
Thanks, Ben. Please don't say that.
Did you know that they won?
Who? La Laura.
Did You know that she's gonna go to her senior night?
No way will
Yeah,
I
I texted her on Facebook.
Why? You texted her.
It doesn't make your flowers.
Oh, yeah.
Count.
Either way, time makes
What is it,
sense.
just?
Either way, time makes sense.
It's kind of like this one, but like six the opposite.
85. Yeah. How you doing?
Good.
Good weekend?
Mhm.
Well, Evelyn, did she have a good weekend?
Yeah, pretty
What
good.
happened?
Evelyn. How we doing?
Good.
Good weekend? Anything? How are you? Good. Good sense? Maxwell? Oh.
Yeah.
Wait,
Domain range and
I got it for the domain.
Whoa!
That scared me.
Stir beef.
Yeah,
Oh,
last week, I watched the videos. Is there any kind of like in class Friday?
No.
Or is it included in the videos?
Just that Friday, I posted the blonde video, so I'm gonna try to get the review up there.
Pretty good, pretty good.
Good question.
Just 4.
Not really.
How you doing? Good, good. Good sense? Yeah. Good. This, the only thing for this range guy here, what I do want is when it's a singular number like that, I want that roster notation. Good? Yep.
Was good.
Let's just shoot today.
5.
No, man, you're ahead of me, okay?
Why don't you hurry up?
No, so on the domain,
It's
all real numbers. On the range, it would in fact.
2 minutes, 2 minutes.
Thanks, man.
It's only.
There's a backpack.
Just Yep. Exactly that roster notation.
We made it.
Well, that's about trans.
Negative 3, negative 2. Oh, negative 2.
We had a special ceremony today in calculus class. Complete with awards, speeches. We had refreshments, and snacks.
You know what special day it is today?
Oh,
I forgot! Yeah.
Oh, we forgot.
At the end of class, we will celebrate Ben's birthday.
Ben, what the heck? I completely forgot. You're like,
We literally talked about this during lunch, right?
What is
What,
today's
yeah?
date?
You guys?
It is the
Yeah.
2nd of October.
Your birthday.
That is my birthday.
Did you fill out the birthday sheet, Ben?
Yeah, it did.
Then why is it not on here?
Did you select the
Oh,
random date?
because you put 2006, not 2023. Got it.
I thought it was like
Got
actual
it.
birth year and
Okay,
stuff.
I got you. I got you. Yep, that's why I missed it. Man, how did I miss that?
My bad.
That's all right.
Ben,
Okay.
I really
I
like your
didn't
mom's
realize.
face.
We'll celebrate. Just to let you know, I did. I got a present for you. Okay.
Wow,
Yep.
okay.
Oh, that's so. We're gonna be bottoms up with you.
Yeah, we're gonna track this.
No,
Got
we
17
aren't.
of them.
No,
Yep.
we aren't. You're gonna get 17 shots.
That means you bend over in front of the goal and we take 17 shots right at the end. How awesome.
We didn't do it for Mike. We're
Yeah,
not
we gotta
gonna
do
that's
that.
because
That's because.
We're out of time.
Yeah.
Mikey's a wimp.
Yeah.
he would never.
It's light.
I'll take 17 shots. You're really gonna like it.
No.
We don't have a season by my birthday.
Yes, thanks. More of a March guy.
March is such a weird.
I know, it really is. Isn't it like 5 or 6 of my family members have birthdays in March?
What?
I know, it's the birthday month of my family.
Hannah, do the goats ever get too hot? I'm guessing they're really looking forward to the weekend, aren't they? It's gonna be down in the 50s.
Yeah.
gonna be cold.
I can't wait. I'm going camping this weekend. Gonna sit around a campfire a little bit. Okay, pause, go back to your notes, Hopefully you got a little bit of time to practice there. Start that assignment. You're gonna come back to this part of the notes right here. So this is the part that I'm gonna work really hard to try to make sure that we understand, but inevitably, it seems about a quarter of the kids really struggle to get it, okay? So just kind of high alert, you're gonna have to focus, and if you don't, you're just gonna get, and this isn't the only test of the year that you gotta be able to perform this on. This comes up again and again. So we'll do our best. You don't have a graph. You just have x squared. What's the domain?
All real numbers.
Why?
Because the x squared is a parabola.
Good. So Ben sees that it's a parabola, so he can picture that graph and say, I know exactly what that graph looks like. And so I can tell that it's going to be all real numbers. But in the definition of domain is all of the available numbers that you can plug in and come out with an output. For example, let's try a positive number. What is 9 squared? 81. What's 1 squared? 1. What's 0 squared? What's negative 3 squared? See, it doesn't matter what number we grab. When we square it, you get an output, right? Suppose I take a fraction like 4/9. Well, 4/9 squared, that's 16/81. Like, you get an output every time, don't you? This one's different. There's one spot where I don't get an output. Anybody know the number where I don't get an output?
3.
3, why?
Can't have 0 on the bottom.
Because that would produce 0 in the denominator. The domain is x cannot be 3. Or in other words, the domain is from negative infinity to 3, union 3 to infinity. I'm not worried about the range right now. I'm only going to produce the domain. And this graph looks like this. I'm going to sketch the graph right here. Do you see from that graph that x can be every single value except for 3? That's what it looks like.
Yeah.
Okay. How about the next one? Don't look at the graph because you don't see one. Are there numbers you can't plug in for x?
Bigger than 4.
Let's try 5. If I plug in 5, 5 plus 4 is 9, square root of 9 is 3. 5 works. 5 is part of the domain. Can you think of a number that wouldn't be part of the
Like a
domain?
negative number. Like anything below negative 4.
X equals negative 3. Negative 3 plus 4 is 1. Square root of 1 is 1. But as you then said, let's try something less than negative 4. Let's try x equals negative 5. Well, negative 5 plus 4 is negative 1, and the square root of negative 1 is imaginary. So see what he said? He said you got to choose something that is bigger than negative 4. Negative 4 or bigger. He's absolutely right. And what would be the work that we would use to come up with that? We would say that x plus 4, that part that's underneath the square root, we would say that has to be greater than or equal to 0. As you subtract the 4, we have x greater than or equal to negative 4. Here's what the graph looks like. And when you see the graph, it's pretty easy then to know what the domain is, isn't it? Yeah. So that's your goal, is to be able to just look at the equations and know what the domain is. So let's try to categorize these into 3 options, okay? Let's try right about there. We have polynomials, and polynomials are things that look like this. Say y equals x to the 4th minus x squared plus 1, okay? Or y equals 1 minus x cubed. Those are polynomials. They are variables with powers, expressed as multiple terms, and their domain is all real numbers. If you have a polynomial, the domain is all real numbers. There are none that have restrictions. Okay? If you just see a nice polynomial, you know it's all real numbers. That's all there is to it. Kind of like x squared, our first one. Rational functions, well, those are a problem. Suppose you had 1 over x minus 8. What number could you not plug in for x? 8, because that will give you 0 in the denominator. That causes a problem. But people often say, well, if it's a fraction, then I know I'm going to have a problem. There are some that don't have an issue. For example, 1 over x squared plus 4, that doesn't have any issues. Because there's nothing you can plug in for x that would make it 0. Ben, give me any number.
1.
1 squared is 1 plus 4 is 5. I ain't getting 0 there. Try a negative number, negative 3. Negative 3 squared is 9, plus 4 is 13. Can everybody see that it doesn't matter what you plug in? The bottom is actually the smallest value you're going to get out of the bottom is 4. That's the smallest number you're going to get out of the bottom, isn't it? So this is never going to be 0, so this is all real numbers. Radicals could cause problems. Suppose you have the square root of x plus 1. Okay, what's a number that you couldn't plug in for x there? Negative 2. Negative 2 plus 1 is negative 1. Can't do square root. Negative 10. Anything that is less than negative 1 can't be plugged in, right? So as soon as people see radicals, they're like, uh-oh, there's a problem. Not the case. Cubed root of x. What's the cubed root of 64?
4.
4. What's the cubed root of 8? What's the cubed root of 0? What's the cubed root of negative 1?
Negative 1.
Negative 1. You can take the cube root of a negative, can't you? Because a negative times a negative times a negative is a negative. So therefore, we don't mind odd roots. Even roots, those are bad. Odd roots, those are good. Okay? So flip it over. Let's give this some practice. We want to classify these in one of those three groups. First one, I see a radical. Can a square root cause a problem? Absolutely. So therefore, we say x plus 2 must be greater than or equal to 0. We subtract 2 from both sides. X is greater than or equal to negative 2. So your domain is going to be from negative 2 to infinity. The next one, which is that? Is it a radical, a rational, or a polynomial? It's polynomial. What's the domain for polynomials?
All real numbers.
That's it. Don't get that one wrong on the test. Agreed?
Yeah.
Next one, is it rational, radical, or polynomial? Rational. Uh-oh, if I see a fraction, that's an issue. I can't divide by?
0.
What number would give you 0 in the denominator? 4. So x cannot be positive 4. Next one, I got a radical. Uh-oh, can I take cube roots of negatives?
Yeah.
Yeah, so is there any problem with cube roots? Absolutely not. All real numbers. Next one, I got a rational function. The bottom can't be 0. Let's see where the bottom would be equal to 0. X squared minus 5x equals 0. How do you solve that? So then F rhymes with actor. Factor. Factor out the x. X minus 5. So you can see that x cannot be which two values? Yep, 5 and 0, or 0 and 5. That's my domain. X not equal to 0 and 5. Fourth root, do those cause problems?
Yep.
Absolutely. 7 minus x cannot be negative. It must be greater than or equal to 0. I subtract the 7, I get negative x is greater or equal to negative 7. And I divide by negative 1, x is less than or equal to positive 7. As we express that in interval notation, that would be from negative infinity to positive 7. And then we get to the ones that start to look a little bit more challenging. Okay, so those are the basic 6 I've got for you. We want to do 6 more today, and then we'll stop for the day. 5 minus x. Here's what I get on the test from everybody. Okay, I get this. X can't be 5. You understand why people write x can't be 5? They're like, well, 5 gives you 0. They just get used to like, oh, we don't want to come up with 0. You can come up with 0, you just can't get 0 in the denominator. Well, there's no denominator here. 5 minus x is just a line, isn't it? Just looks like that. What's the domain for a line? Oh, remember, this is just a polynomial. The next one is say, oh, well, that's a fraction. So you got to have a problem there. Well, actually, this is not a rational function. This is a polynomial. See, I don't have an x in the denominator. I just have 5 in the denominator. This is 1/5 x squared minus 1/5. That's all that is. That's a polynomial. It's a parabola, right? The domain is all real numbers. Oh, the next one, well, that's a fraction, so I got to have a problem with this one. Can x squared plus 1 ever be equal to 0? Absolutely not. That bottom is always positive, no matter what. I don't care what number you plug in for x, you're going to get a positive number out as a result. Domain, all real numbers. So we do these last 3. This one, I have a little bit trickier solution here. This one is a radical, and it's a square root. I know that square roots cause problems, so I set up 3 plus 2x minus x squared must be greater than or equal to 0. Wouldn't it be nice if we would have had a problem like that in our last test to prepare us for this moment? We did, didn't we? Yeah, didn't we have quadratic inequalities on your last test? Remember how we solved this? We multiplied by -1 to get x squared minus 2x minus 3 is less than or equal to 0. And we said if you have a quadratic inequality, you have to make a table or a graph, one of the two. So we factored to get x minus 3 times x plus 1 is less than or equal to 0. So this is a graph that goes through +3 and -1. It's a parabola that's right side up. Am I wondering where this is above the x-axis or below the x-axis? Because I'm wondering where it's less than or equal to 0, I'm wondering where it's below the x-axis. And that would be from -1 to +3. The next one, square root, that's a problem. X squared plus 2 must be greater than or equal to 0. X squared plus 2 must be greater than or equal to 0. Uh-oh. That doesn't factor, does it? So let's check out the graph. What does x squared plus 2 look like? What's the shape?
Parabola.
Shifted
2 to the right. Or 2 up, sorry.
2 units up. We're wondering when this thing is greater than or equal to 0. When is it above the x-axis?
It's always.
All the time. And for this last one, we have -3 minus x squared is greater than or equal to 0. Do you want to get rid of the negative? Or should we just graph it like it is? Which one do you want? Oh boy.
Attention music students. This is a reminder to pick up your butter braids in the commons right after school. Again, music students, remember to pick up your butter braids in the commons right after school. Thank you.
All right. Diego, do you want to get rid of the negative or do you want to keep it? It's up to you.
Get rid of it.
He wants to get rid of it. So we're multiplied by -1. I get x squared plus 3 is less than or equal to 0. Okay? That doesn't factor. I'm going to look at the graph. It is shifted up 3 units. When is that below the x-axis?
Never.
Never. So therefore there is no domain. We actually call it the empty set. If you were to write an empty set, it would look like that. You don't have to write that symbol, but that's what we say. So you've now seen domain 2 ways. You've seen it graphically, which is this practice here, and then next page is just the front. Now I'll be looking at the domain analytically. And some of these could go rather quick. Notice that number 2, it's a polynomial, so therefore the domain is all real numbers. And the next one, you can see x is not going to be 3 or negative 3. So some of those could go pretty quick. You guys stay with it. I will give you an update on our schedule tomorrow. Just people have been gone at the museum and all things updated so we can figure out where we should be when. Okay? Good job today.